so conventional current versus electron flow. Well, so basically the electrons are flowing that way around, but the current is flowing that way around. So it's saying, how can that be true? Well, essentially, it's because electrons are negative, which you've said in your answer here. But let's try to understand it a little bit more of a deeper level. So, what I'll do is I'm going to make a bunch of electrons, and then we're going to think about what current means, and how it would change with electron flow. So I'm just going to pause it and create some electrons. So here we have a bunch of electrons. Now the current is going to the right, but the electrons are actually going to move to the left. Let's try to understand why, and to do that, we're going to think about what. Okay, let's just look at it first. So this electron here, is going to move to the left a little bit. That allows space for this electron to move, and also it's going to be repelled from that electron. So that's going to move a little bit that way. Now that one's moved, there's space for this one to move, and it's going to be repelled from that one anyway. So I'm just going to move that one back a little bit. Let's move that one there. And so the process keeps continuing like that, and so on, right? So the electrons are moving from right to left. But how is that how is that the current moving from left to right? Well, if we go back a moment and we repeat that process, let's think about what before we do actually. Let's think about what current is. It's the rate of flow of charge. Now, oh my god, the rate of flow of charge. Now, if we don't stipulate what do we mean? Do we mean positive charge or negative charge? Then really we have to assume it's positive charge. If we're talking about how much charge is increasing and in what direction, well, at the moment this little gap here is more positive than that electron there. So this gap has a charge of 0, whereas all around it there's a negative charge. Now, if I move that negative charge and fill that gap, the gap has become more negative, and there's a new gap in there that's now was negative. This space was negative, and now it's positive. So in a way, as we move the electron to the left, the positive charge is moving to the right, or the right hand side is becoming more positive. So we say that that the current has increased, is moving to the right. With every movement of electron to the left, the right hand side becomes more positive, especially when you consider that everything's made out of that the metal is made out of protons as well as electrons. And so when you move an electron away from something, it was neutral and now it's going to be positive. So actually it really is that positive charge is essentially moving to the right, even if it's by virtue of the negative charge moving to the left. Okay,